Gasless flux core. You guys have asked for it enough. We're gonna do some demos. This is again gonna be catered to the intro, the hobbyists, the DIYs, those folks that are just getting into their first welding machine. Do they need gas? Is it worth it? Can I just get by? Well, let me tell you, you can do a lot with this gasless flux core wire and doing general fabrication, even up into the really heavy stuff. Let's have a better understanding of that welding wire. Let's go over to the whiteboard. Now this is likely going to be way more than you asked for, but this is the layout of my brain basically. First we're going to talk about gasless flux core wire. This is all gasless flux core wire. What we're going to be looking at is what you're going to be trying to figure out what to buy at the store, and this is what it's going to be labeled as. E for your electrode, 7 for its tensile strength, so this in this case is going to be times 10,000. This could be either a 0 or a 1, 0 being flat or horizontal and a 1 being all positions, as these that we're going to be dealing with today are. And the T meaning tubular. Tubular meaning the inside of this wire is hollow, unlike the MIG welding process, or gas metal arc welding is a better term, that has a solid wire. This is tubular because all the flux, all the good alloys and all the good bits are in the inside of the wire. That makes this wire size anywhere from 030 to 072 or 5/64. So that's like really thick stuff. It's like sheet metal moving down to heavy stuff. They don't go much thinner than that because it's hard to fit all that flux inside of a wire for it to fit. But even getting up into this bigger wire, I mean, man, they use this for big, heavy industrial stuff. It's not just a hobbyist wire, it gets up there. And then that leads us into this little dash and S. This in most cases will mean that it's its self-shielded flux core, which means it doesn't need an external gas, no gas needed for these process. In order to get a thin slag, we gotta weld it on DCE, and it's good for general and heavy fabrication, as we already talked. This is gonna change because some of the wire manufacturers like to have different names for this stuff, but they're all going to go under the same AWS classification of 5.20 for coated electrodes in flux core arc welding. But it might say GS, which means it's a single pass, like it's not meant for multiple layer fillet welds or anything like that. Or it might say -11, which is for your limited multi-pass. We're not talking about if it's a thick 1-inch section and we got to put a bunch of welds. That's not what it's meant for. But if you got to do 1-2 passes, and that -11 might be it. You might see these other numbers on here, and this is Lincoln Electric's way of what they're calling it. This NR211 is the same as these two right here because they fall under the same AWS spec as well. But the NR232 is going to be something for that heavier stuff. You know, it's going to be more heavier fabrication. It's going to fall under a different spec. And the NR203MP might be something even for, believe I dare say, open roots. The point of this whole demonstration and the scattered that is my brain is to show you guys that this isn't just a one-trick pony process. You can do a lot with the gasless flux core wire. Now that we know a lot more about the wire, let's run to the store, let's go pick some up and find what this is on the shelf. Oh, you know where we gotta go to get some quality self-shielded flux core wire. The old Harbor Freight. Of course, like right when you walk in, you see all the welding equipment, so you know you're in the right spot. And then boom, there you have it. We've got our Vulcan. This is what we're looking for, guys. We're looking for the size E71T GS. That GS is what's going to say, well, that and all this across the top, but the size is what you're looking for. If you're welding anything 1/8 inch and under, you probably want to go to something that's 030 size. It's a little smaller, easier to weld. If you're welding off 110, that's what you're going to be wanting to weld off of. And then you have, of course, your 035. Today we're going to grab some 030. Now I'm not going to lie, for 030 2-pound spool, 23 bucks, it's kind of highfalutin stuff right there. That's inflation. You can get on Amazon, you can scroll through and you can see different prices. One thing I will say about any type of filler metal that you buy, you might be able to buy 5 different brands of 7018. Believe it or not, they all run a little bit different. And the cheaper you go, you know, you get what you pay for. It might be the same stuff, it just might be better quality. So I do have some of this wire, and my favorite go-to on Amazon is that Blue Demon stuff, and it's like 10 bucks cheaper. So got some of that at the house, and it might be better, it might be worse. I'm interested to see what the difference is. Now that we've got our wire, got our GS wire from Home Depot, and I've got this Blue Demon -11 stuff. So one is for your single pass, one's for limited multi-pass. We'll see if that makes any difference for welding some simple square tubing, because that's all we're trying to do. We're not trying to get too in depth with all these crazy different things that are a gasless flux core. We just need to know how to set up the machine. So just to run it back, we don't have to plug anything in the backside because there's no gas. So that being said, the first thing we need to check on, make sure you have the wire running the right direction when you go to put it on the spool in the first place. Take off all the little pieces off the spool carefully. Make sure you pay attention to how they came off so you can put them back on the exact same way. Depending on what spool you use, you might need a different piece or two that the machine should come with, or you might need to remove a piece because it doesn't fit these small spools because the holes are different. Anyway, make sure you have that wire roll in the right direction. If it's not, it might cause some wire restriction. The next thing you need to know is running into your drive rollers. Gasless flux core, like we mentioned, is hollow. It's tubular. It's got the flux on the inside. It makes it a little bit more soft compared to hardwire MIG, which is a solid piece of wire. That being said, we don't need as much tension. If we tension it down too tight, we can end up pinching it and breaking it, and then we just gotta run all that wire back, pull all the bad stuff out, and it's really annoying. So we gotta make sure we have the right tension. Not only that, but we wanna make sure we have the right rollers. These are called knurled rollers. Say it with me, knurled. I know it just absolutely messes me up, just the way it's spelled versus the way it's said versus the way they look. They're knurly. They've got little grooves. They got like teeth on them so that you don't need as much tension and it can still grab and pull. So we're gonna swap out those rollers to some knurled rollers, and you'll notice that these rollers have different sizes on them. So one says 0.8, one says 0.9. That's gonna be your 030 or 035 size wire. Some machines will say that the number needs to be facing you and that's the side that you're using, and some don't follow that rule. After we move that, you'll notice on the inside of this machine you have this little cable that runs up in there. That's your polarity for your MIG gun itself. You need to actually swap that. This self-shielded flux core, gasless flux core, whatever you want to call it, that's usually what I like to call it, is self-shielded. You have to switch those polarities over. Right now the gun is sitting in the positive terminal. We need to put it into the negative. So we'll undo that, move it to the negative, and now that we've got everything that we need from wire all the way through our drive rolls running out, now we got to get to the MIG gun. I opt to spend a little extra coin through distribution, you know, go down to your local distribution shop and find one of these Abbey MIG guns. I got a good feel of these probably 5 years ago at FabTech, and I just didn't realize that they come with a lot of machines, but you could also get adapters to fit whatever machine you have in order to run this style MIG gun. The reason why I really like this is because of just how flexible and ergonomic the trigger looks cool. I think it just overall just is a nice piece of equipment. First thing that goes on the tip of your MIG gun is going to be your insulator. It keeps and protects your consumables, so you want to make sure you have that on there. Otherwise you'll have live things showing, like the diffuser could be showing if that insulator isn't there, and it could arc up on something, and we don't want that. Our diffuser is here to help hold our contact tip and our nozzle in place, and that's where the gas would come out if we needed gas. The most important thing is we have the right contact tip size, the 030 size tip. If we had an 035, it'll weld, but it welds a little bit crummier because it's like not staying in contact with the tip all the way around, thus giving us a really poppy sound. You can also run the nozzle. The nozzle's there to protect all those consumables as well and help direct the shielding gas if we had any. You can actually run this process with or without a nozzle. We're gonna opt to running it with the nozzle today, just so I don't tear up some of my consumables. And then we have our ground. We have our MIG gun plugged in. We changed it to negative on the inside, so that means we do not want to plug it to the negative on the outside, but we have to plug it into the positive so that we're running DCEN. Whew, that's everything you need to know about running this wire through your machine. Now we just want to run over just the last few settings before we start welding. Now this Hurricane is a multi-process machine. That means it'll do MIG, TIG, stick. This one even does AC/DC, TIG, and plasma cutting. So it is a one and done machine, so you can see it has all those options across the top. We are looking for that FC, no gas. That's what we're welding today, flux core, no gas. Once we got it to that setting, we can adjust our volts. This is a constant voltage process, so we are going to be adjusting our volts and our inches per minute. Likely we're going to need some higher inches per minute. We're running on 1/8 inch material. We're going to run some practice beads before we get running onto our project. This does have what's called a power set mode too, so that you know that you got no gas. We're going to be welding on 1/8 inch material, okay? And then we can come over here and we'll choose our wire diameter. Is already on 030, so it's already setting our voltage for us at 20.7 and 350 inches per minute, which I think is pretty intense. Right now we're running off 220 power, 220 voltage. We're gonna have as much power as this thing can push. If you're running on 110, because that's the only thing you got, this is a great option for that. The 030 size wire. Going up in wire size might not be your option, but upgrade to 220 if you can. If you can't, it's okay, but you won't need this big of a machine. You could check out Everlast's other options for a much smaller inverter to do this. We're also gonna run our wire. We've got that wire jog feature, so we're running our wire through our gun right now. The wire is really soft, So I like to take off my contact tip. Sometimes that wire will run through that diffuser, hit the backside of something or that contact tip, then it just bird nests inside the actual deal. So make sure you don't have any loops, or everything's just strung out as good as you can, so that as this runs through, you don't get a bird's nest, which I actually think it's getting a bird's nest right now. I can hear it. Yeah, baby. So I pretty much know what happened. You can see the wire ended up breaking right in there. I ran this wire without the MIG gun on it first, so I ran it all the way out. The little bit of wire was sticking out right here, and I just put the MIG gun on and hit go. You really should manually hand feed into the gun a little bit further, because it probably got maybe that far before it was like hit, it got in a bind, and then it just started coming out where it could. So now we run it back through, clean it up, and run it back through. Pull this little wire out of what went in, see how far it actually went into that MIG gun. Ooh, it tried. It didn't make it very far. Now we got that, we'll cut it back here where there's good stuff, pull that out, and then we can run this back through. I say I had good tension, it was definitely pushing wire, but it was stubborn. So make sure it gets in this time and manually feed that through a little bit and then latch it down. Hey everyone, I probably look like a familiar face. That's because I'm that guy. And what Past Austin doesn't know is right after this, his microphones would soon die. And he wouldn't figure out till later on in the video that they were dead in the first place. So a lot of this video sounded like I was in a box. Nothing will make you madder than back-to-back bird nests. That being said, we're reshooting a portion of it. The MIG gun that he was trying to feed that wire in didn't have a liner in it. So we got a lot more bird's nests after that. A little bit of frustration and some problems and some issues as he kept trying to put wire through without a liner. How ignorant. Put a new liner in and we are good to go. So now we're just tacking up our coupons. We're gonna tack up two different variety of coupons, and that's going to be our 45s. That's gonna be our 45 joints and our T joints with our square tubing. What Past Austin also gave you just absolutely miserable advice on is that you don't need this nozzle on that actual MIG gun to do this self-shielded flux core. Now, while that's true, it's because there's no gas, you are leaving all of the contact tip and the diffuser exposed, and if you're laying it on a table, you'll arc out on those and ruin your consumables. You know how we said we don't need a nozzle, blah, 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 blah. This has gas, that's why. So just go ahead and keep that nozzle on as you go doing any type of welding whatsoever. Now that all of our weld joints are nice and tacked together, we tacked everything with the power set mode on this Everlast Hurricane, and it set everything to about 20.7 and 350 inches per minute. And again, we just set that to the wire diameter, and the material thickness, and the machine here gave us the settings for us. We're gonna maintain about 5/8, half an inch or so as far as away from the material. We're gonna drag every weld. We're not gonna do a whole lot of motion unless we have to. We're just gonna judge that based on our travel speed. This wire seems to burn in pretty decent. If you play with your distance from your material to your contact tip, you can find that little sweet spot on where this runs the best. Welding on these sides of the square tubing that kind of have that flare bevel to them, we want to favor that flare and less of that tubing edge. This one's a little bit better together. And if you get that kind of slow to start, that spitter and sputter, play with that arc length a little bit, or you might be getting some wire feeder problems just like Past Austin had. That's probably one of my least favorite parts about this process. Sure enough, that wire broke off. If you don't have those drive rolls set perfectly, you're gonna end up snapping the wire off in the machine. Maybe the tension was too tight, maybe it wasn't tight enough. We gotta just play with it. Typically, if a wire is snapping like that, and you got everything set up as far as wire feed and all that, it might have been too tight. That wire is really soft, it's really easy to break. All I did was loosen the spool a little tiny bit, and then we loosened the tension quite a ways, and it even stopped making a little sound it was making. Let's try it out. That seems to be a lot smoother with that tension there. You'll see a lot of the times your arc might spitter or sputter, especially at the start. I would recommend just kind of pushing back into that weld, pushing back, and making sure that puddle gets established before you try taking off. I'm starting to hear that little bit of sound in that wire feeder, but it's welding okay. Trying to maintain that 1/2 inch. I don't want to see too much of that sputter or that wire jumping like that. That's telling me that there might be still some tension adjustments. Before we inspect all these and get the slag cleaned up, we'll go ahead and weld this butt weld here. Oh yeah. No motion, just keeping a nice consistent puddle staying in it. And this stuff welds really well. You'd really be hard pressed to see the difference between that and say like a 7018 weld. I mean, you could tell. There's no trick to this. You just need to get your wire feeder set up properly and make sure that you really follow that contact work distance. Having a lot of loops in your MIG gun is going to cause some wire restriction. And that wire being so soft, it's just really easy to break, and it's very frustrating of a day if that's your whole day. This is welding really nice, this wire from Harbor Freight. I'll weld a little of this downhill, see what happens. Ooh, we got porosity on that. Lots of porosity on that downhill. It welded good on that flat and horizontal. We'll clean this up and take a better look right now. All right, let's clean up some of this weld. You can use one of these Scotch-Brite wheels from 3M as a wire wheel too. It doesn't remove a whole lot of metal, and it doesn't leave a whole lot to the imagination. It's gonna definitely clean up your weld really nice. We can see just a little bit in that crater, maybe a little bit of porosity. The back side, we can see we got a lot of porosity trying to run that weld downhill. That one there looks real nice. I like the way that one turned out. These aren't the best for in a corner, but you can still get in there. We can see that weld on the inside looks pretty good. I mean, those are some solid welds. Even if you didn't like the way they looked, you could still take your 3M abrasives, your fiber disc, and slide that old dog on your grinder and blend that weld down, and then come back if you really wanted to get a nicer finish for paint or anything with one of these Scotch-Brite wheels so that everything blends in properly. You can use a wire wheel. It's really easy to clean up a weld too. Make sure you respect your wire wheel, folks. If we look at this weld all the way around, could get into our craters a little bit better and wrap into those. That's really the only thing I'm seeing. This is where we spittered and sputtered a little bit more, but once we got that machine tension dialed in, we ended up making some pretty good welds. It's just a slag, a little bit of a 10-degree drag, not a whole lot to the process, just maintaining that contact tip to work distance. If you're sitting there and like popping and sputtering, you have too much wire restriction on the actual wire feeder, or maybe you're too cold in your voltage, or maybe you have too much wire going out. Make sure that you adjust those things, because that's what you'll see a lot of the time. If it's blobbing on you, you know that your voltage is too high and your wire is too low. But outside of that, we're gonna go ahead and swap these wires out from the Harbor Freight wire that we used. This was that GS, that was a single pass. We'll move into that -11 from Blue Demon. We're not gonna put any multi-pass welds, but we're gonna kind of see what the differences might be. Now, when you're going to take out wire that's already in there and you're just swapping out wires, you didn't burn nest nothing, I always think it's a good habit. Go ahead and clip that wire at the end of the gun, because sometimes there's a little bit of schmutz on the end. Won't allow it to get pulled back. It's a good habit to roll back your wire onto your spool. You're gonna end up saving some wire in the process. Now, if it snaps over here, you gotta pull it back out through the MIG gun. However, if we can just save a little bit of wire, all this stuff costs money. And then go ahead and hook it through there so it doesn't bird nest, and then we can remove it. We're gonna put this other wire back on. Go ahead and put on our bits, tighten this up. I just want to get some threads on it. This I don't want to torque down. Just get a couple threads on it. Pull that wire out, snip it and clip it. I always try to take the little bit of curl out of the front of the wire, just so it goes in straighter as you try to feed it through everything. Once you get it fed through the gun a little ways, snap it down, Grab our MIG gun, make sure there's no loops in it. Get our machine powered back on. And then hit that wire jog to jog our wire through. I usually like to take this contact tip off. We'll see if it makes it out. If not, it's probably gonna snap that wire. I'm too nervous. I gotta take this contact tip off. I do not wanna run this spool back on. This wire here, again, remember we found it on Amazon for almost $10 cheaper than the other spool. Seems to be a little bit more, I don't know, seems harder. Like it doesn't seem as soft or easy to bend. Definitely feels a little bit different as far as its malleability. That's the only thing I can really tell right off the jump from this cheaper wire than the wire from Harbor Freight. Let's weld the same two coupons, but with this Blue Demon wire. All right, here we go with the new Blue Demon wire. Ooh, definitely seems crisper. I don't know, it seems a little bit hotter. It's laying flatter. Kind of like that. Kind of like that a lot. Seem to be able to move a little faster, maybe. I haven't changed a thing. I like the sound of it. I don't have as much of a stebbing out problem so far. The wire seems to burn really good, really easy. The starts seem a little bit quicker too. It's interesting. Interesting. I'm gonna put a little push in it, see what happens. Seem to actually lay down pretty good. Let's try these butt welds right here. Try that downhill as well. I don't know, this seems a little different. This butt weld seems to be stacking up a little higher. Maybe if we change our gun angle to a little bit more perpendicular, yeah. Less of a drag, more of a straight in. So let's go straight in with it, see if that works better. Oh yeah. About ½ an inch of contact tips to work distance. You can probably get away with closer. And remember, if we were running, say, this on DC positive, it just welds with a lot more spatter. Lots of spatter. So if you're seeing your weld that has just spatter on everything all around you, you might want to check your polarity. Yeah, this one's just not, it's just burning. Seems to burn a little better. And remember on that last weld that we did that downhill weld, and it got porosity. See what happens here. I didn't see any porosity on that one. No, there's a couple little pinholes, but we can get a closer look. Now let's take a closer look at these welds just so we can kind of compare them a little bit. So on this one, we got one tiny bug hole there, maybe another one on the start. I like the profile of these beads a little bit better. We do have the occasional pinhole. Probably with what you're doing, it's probably not the end of the world to have a little pinhole here and there. It would be something to kind of figure out why those pinholes showed up. Curious enough, where they have porosity is in those corners, and I actually tacked that with the other wire. That other wire is not made for limited multipass, and this wire is, because it can weld over itself without any issues. But overall, I really like that Blue Demon. One thing before I let you guys go is I want to give you the old sock check, fool. Camel Mill socks. Oh, I don't normally do these kind of things, but man, these socks are absolutely 100% the best. Not to get too much on the TMI, I got some of that athlete's foot that I always have to keep away. These socks keep my feet really, really dry. They have all these nice little bumps and grooves, reinforced toes, and even little vents right above your toes to help let them old dogs breathe. If you go to their website and type in Weld10 or use the link down below in our description, we can copy a deal on those socks. And again, I wouldn't plug them so hard because they're just socks, but dude, socks really help. I don't know if you wear his boots as often as I do, but socks make the world of difference. That, and you can use code Weld10 at Outlaw Leather with the link down below so you can get 10% off on your welding hoods or other welding accessories. Now that we're done with that, let's go check on old Pass Austin and see how his coupons are. You gotta be kidding me. That broke again. Son of a biscuit. I'm officially butthurt. It's kind of a pain in the butt, and I've used this machine on a lot of other wires. Never a problem. I'm sure once I do it right, it'll do what it's supposed to. But until then, we're snapping wires. I swear if it does it again, this video is over with. We're done. Now we're back to cooking again. Minor setbacks, people, minor setbacks. Starting to weld real good now. Okay, okay. Yeah, that's smooth. That's smooth now. Don't run that thing downhill. Got a whole bunch of pinholes. Uphill's just gonna make a hole. Well, the weld shines up good. The big point of this video that I wanted to get across is you can make really quality sound welds with the gasless flux core process. And remember, this is the light duty stuff. This is 030 on 1/8 inch material. This stuff gets way bigger and way more serious as you get up into those wire diameters. If you want to see some of those types of episodes, let us know. I'll go find someone that's got some of that stuff laying around and we'll weld it together. Outside of that, you can make the same quality weld with or without gas. The biggest thing is fighting that wire feeder, making sure you have the right settings. It's just like any other process. You have to have all the things set up properly in order to make a good, clean, nice weld. This one has a little bit more to do with the wire feeder, and probably my least favorite part of the process is having such soft wire always seems to want to fight in that wire feeder. If you can get past that, you get everything lined out well, regardless of whether you choose the more expensive wire or the cheaper wire, I think they'll both do you pretty good. The biggest difference that I've seen on these two wires, more expensive stuff didn't lay down quite as nice on the butt welds. It humped up a little bit more. On the insides, they look pretty similar. I don't know why the more expensive wire seemed to get a couple more pieces of porosity in the weld, whereas with the cheaper wire, I didn't get a single pinhole until I went downhill. When I went downhill, we got nothing but porosity, whereas the other one allowed us to go downhill with more or less none. So that's a little bit interesting. I hope you found that some good information. Go check it out in the description below. Oh my goodness. Check out our links in the description below, and we'll see you on the next weld. It's a one-trick pony process. You can do a lot with the gas shielded process, or you could do a lot with the self-shielded gas process. Why am I keep saying gas?